welcome back. We're going to do question 4, okay, for June 2018 paper. So I'm going to write this as if I'm just writing the exam, and then I'm going to explain to you afterwards. So I enjoy the music. So question 4 says nitrogen gas and hydrogen gas react in a reversible reaction to produce ammonia gas. You're asked to define the term reversible reaction. Okay, so you have to define this term here. So reversible reaction doesn't mean a reaction that can be reversed. So it can be a bit confusing. It doesn't mean that. What it actually means is that the reactants will be converted to the products, and the products will be converted to the reactants, and this takes place at the same time. Okay, so a reversible reaction, it's the conversion of the reactants to the products and the products to the reactants, which takes place at the same time or simultaneously. So the B part actually illustrates this. So normally when we would write equations, we would write them like this. So A plus B leading to C. But then for this part, you don't do that, because this one, it's a reversible reaction. That means that it's actually going in this direction, and it's also going in the backward direction as well. So you have nitrogen combining with hydrogen here. So I was supposed to write 2 here. This one is supposed to be 2. Okay. So you have nitrogen combining with hydrogen here. This is hydrogen, and you have ammonia, so which is NH3 here. Okay. And you also have NH3 breaking down to give nitrogen and hydrogen. Okay, this is happening at the same time, and you have to have conditions which we are going to look at very soon, that actually allow you to have more of the ammonia. Since you want the ammonia, you can set the conditions to favor the forward reaction or the production of ammonia. So the other important part was to actually balance the reaction. So I'm going to rub this, and then we're going to do this together. Okay, so the first part about balancing reactions is you actually have to get the reactants and the products right. So this one N2, and then this one H2, and then you have NH3. So these are the participating reactants and the products. Okay, so here what you notice is that you have NH3 here, so that means you have only one nitrogen atom on this part on the right hand side, and then you have 2 nitrogen parts on the left hand side. So you can actually make them 2 for 2 just by putting this 2 here. So you have 2 nitrogen atoms, and you have 2 nitrogen atoms here, so it's in balance. Okay, so on the right hand side, you now have 2 by 3, which you call 6. So you actually have 6 hydrogen atoms, and on the left hand side you have 2 hydrogen atoms. You have to balance this, so you have to put 3 here. If you're doing chemistry, one of the easiest tricks here would be to recognize that these are standalone. So you have a standalone molecule here, you have a standalone molecule here. These are easy to correct for. So what you just have to get right is this one. So that's why you have to put 2 on this one first. Okay, not correct for anything here. So when you put 2 on this one first, then now you can go and then adjust with your standalone elements here. Okay, so standalone molecules for our case. Yeah, so this is just about it for the B part. And on the C part, you asked to state the conditions for the maximum yield of ammonia. So the one of the conditions is obviously high pressure, and the reason we want high pressure is the number of molecules on the left hand side here. So for this one would be 4 molecules, and then for this one it's just 2 molecules. So if you increase the pressure, obviously you increase the yield on the right hand side here, so you actually get more ammonia. This reaction, it's actually so another thing that you have to get right is the temperature. Okay, so the temperature, it's a compromised temperature. It's 450 degrees Celsius. This is considered low in the industry. Okay, so and then the third part is ion catalyst. So ion catalyst is you use it to speed up the rate of chemical reaction. Okay, so it actually lowers what's called the activation energy for these two to react. Okay, so instead of these two climbing a very tall mountain in order to get to ammonia, you actually have the catalyst coming in, and then it's just a small mountain that it has to climb, so the reaction would be faster. So explain how any one of the conditions named and leads to an increase in the production of the yield of ammonia here. So you can use catalyst. So this one lowers activation energy. If you want, you can just choose not to put this one there, because catalyst, the function that it serves, it's similar to that of an enzyme. So you can just say speeds up the rate of chemical reaction. So it will be fine like that. But then if you want to know how it speeds up the rate of chemical reaction, it actually lowers what's called the activation energy for the reaction. So for these two to react, they need to be activated. So there is a certain threshold or a certain minimum energy that's required. So if you put a catalyst, you actually lower that. That's why I was putting that analogy with the mountain to say, oh, normally it has to go through this mountain, but if you put a catalyst in, then it's just a small mountain that it has to get through in order to produce ammonia here. So that's just about it for this question. Thanks so much for watching. Make sure you like, share, and subscribe. You are out.